Okay, let's do an extreme algebra question for fun. Here's the question. If a plus b plus c is equal to 1, and a squared plus b squared plus c squared is equal to 2, and a cubed plus b cubed plus c cubed is equal to 3, then let me ask you guys, what's the value for a? And we know the fourth power is going to be too easy, so let's deal with the fifth power. Let me ask you, a to the fifth power plus b to the fifth power plus c to the fifth power is equal to what? And as always, please pause the video and try this first. Okay, so of course you see the first power is equal to 1, and then the second power is equal to 2, the third power is equal to 3, the fifth power is equal to 5, right? Happy April Fool's Day, yay! And as always, that's it. Okay, just kidding. If you end the video, then no. The answer to this is not 5. In all serious business now, the answer to this right here, it's equal to 6. Why? Because 2 times 3 is equal to 6. No, that's a joke again. Why? Because 1 plus 2 plus 3 is equal to 6. Sorry, no. Okay, in all serious business, this right here is really interesting, and I can tell you guys a lot of new identities. Maybe you haven't seen it before, but it's pretty cool, all right? Especially you will see this in discrete math in terms of, for example, you guys know about Pascal's triangle. But have you ever thought about, do you guys know what a Pascal pyramid is? Like the 3D version. So I'll go over that right here as well. And we'll just do a lot of algebra right here. So that's why I call this the extreme algebra question. So here we go. So in all serious business now, okay, to get the fifth powers by using these equations, of course, you can look at the first equation and just maybe raise both sides to a fifth power and maybe work something out, right? But don't do that. Life doesn't have to be like that. Okay, so if you do it like that, leave a comment down below and let us know how that goes. Another way to produce fifth power is, of course, we can multiply this and that, and of course, we'll end up with some other extra terms, but hopefully they are not so bad, right? So what I will do is I will just actually multiply this and that together and see what will happen. So let's make an observation first. So I will just write down a squared plus b squared plus c squared, and then we multiply it by a cubed plus b cubed plus c cubed. So I'll just multiply this out. I will just write down everything. I'm not going to use any of the formulas or whatsoever. So here we go. I will just multiply this and that. Of course, we get a to the fifth power, and then we continue. This times that is plus a squared b cubed, and then a squared c cubed, and then of course you do the rest, right? For the next one, it's going to be b squared times that, which is a cubed b squared, plus this times that, which is b to the fifth, plus b squared. You actually see a really nice pattern for this question, okay? So it's actually no joke, pretty fun. Plus, the next one is going to be b third power c squared plus c to the fifth power, all that. It requires extreme concentration for all this as well, okay? Now anyway, here is the deal. Of course, you can just like write down everything, but like, no, that's not how you're going to do it. You're going to kind of organize the terms in a very nice way, okay? Let's see. We have the fifth power right here, so that's good. So we have a to the fifth power plus b to the fifth power plus c to the fifth power, and that's exactly what we wanted to find right here. And notice, if there's no other terms, then that would be really nice, because this is equal to this times that. So 2 times 3 is 6, you're done. But no, not quite. Even though you get a 6, but not quite, seriously. You still have to face the reality, which is all the rest of the stuff. So check this out. For this and that, we can factor things out. So let's see. If you look at this and that, we are going to factor out a squared and also b squared, right? So I will just write this down with plus a squared b squared. And if you factor that out, we will end up with a plus b. That's nice. It's not that bad. And then next, I will do, let's see if we can factor the b squared, which is going to be right here and right here. You see? We have the b squares we can factor out. So in fact, the c squared too. So we can factor out b squared, c squared, and with that said, we will end up with b plus c, right? Yeah. So we have b plus c. So that's also very nice. And we have this right here. We can also factor out ac squares, this and that. So the last one right here is a squared and also the c squares. So a square, c square, and we have a plus c. So you do have a very nice pattern, but let's see what can we do next though. We kind of need to figure out more things right here, huh? Well, a plus b, it's actually similar to the original equation because, of course, if you look at just the a plus b part, you can minus c on both sides. So this is just 1 minus c, right? So we know this right here is just 1 minus c. And similarly, if you have b plus c, then we can just minus the a on both sides. So that's actually pretty good as well. So we put down 1 minus a, right? Because we minus a on both sides. And then a plus c, we minus the b on both sides. So that is also very nice. Yeah, I think we are doing this right so far, which is pretty good. And now, let's see. This is equal to, of course, we still have the a to the 5th power plus b to the 5th power plus c to the 5th power and all that. And now, here's the deal. I will just multiply this and that, and then we'll distribute to see what happens, and hope for the best, seriously. So, if we do this times that, we get plus a squared b squared times 1, which is just that, right? A squared b squared. And then we will have this times that, so minus c. And let's see if we can do something in our head first. So let's do that, all the distribute with the ones first, okay? So we have this times 1, so that would be this part. And this times the 1, we will have the plus b squared c squared part. And we have ac squared times the 1, so we have plus a squared c squared. So that's very nice. But now we have to do this times that, and that's minus. So we have to minus a squared b squared c, right? And we have this times that is minus a, and we have the b squared c squared. Oh, the a is kind of lonely, but it's okay. The c is only here too, so that's good. And then we have the a squared c squared times the minus b, so it's minus b. Let's put the b out. Well, let's do it in order. We know our alphabets, right? So let's do a squared b to the 1st power and then c to the 2nd power. So that's what we have. And perhaps if you just focus on the last part, all right? So if you just focus on the last part, this right here is the same. Well, let me just put down this right here. It's actually the same as we can factor out ABC, right? Perhaps I will also title this as ABC equation. I don't know, man. So if you factor out the ABC, then let's see, we'll have minus. Perhaps let's factor out the minus as well, okay? We're good, huh? So minus, and we will have AB right here, and then plus. We factor out, yeah, the C is out, and then, oh yeah, so in this case, we factor out ABC. What? Hold on. Oh yeah, we have BC. And then next we have minus, and then the ABC is out, so we have the B is out, so we have A, C, and then this is the plus, like that. So instead of looking at the red, we'll look at the blue part because we factored the out already. So now we know that if you multiply this and that, we get all this. Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 lines. I think that this is my record, but we'll see. All right, here's the deal. I know the value for this expression is 2, this is 3, and if we know that, that would be good, but we don't know ABC, we don't know this guy, so we have to do more work. How can we do it? Well, we have to use the other equations, and we actually have to do the squares, both sides, and all that things. We also have to utilize, yeah, let's use the first one. So let's see. I will look at more observation. Right? Observe. If we have a plus b plus c equals 1, okay, let's square both sides. And look at this is a trinomial. When you square both sides, in fact, you do have a nice formula. I don't know if I should say nice. When you have a trinomial to a power. And this is called the trinomial expansion formula, just like the binomial expansion. But for this one, it's seriously up to you how you want to do it. This right here is still not that bad, so we'll probably just do it by hand. So this is the same as saying a plus b plus c times a plus b plus c. So you can do this in your head and you can just get the following. You will get a squared plus, well, it's like a, let me just write it down for you guys. I think you can still see it right here. So this is a plus b plus c times a plus b plus c, right? So let me just make sure that you guys can see this right here first. Not really, huh? So I don't know, just kind of. Oh, okay, cool. All right, so you just do this times that, which is a squared, and then you do this times that, which is plus ab. This times that is plus ac. It's really similar to that. So this times that, and you get ab, and then you get plus b squared, and then you get plus bc, and last one you get ac plus b times, no, c times that, so c, bc, sorry, bc, and plus c squared, like all this. And technically, I should put down the plus signs along the side here. I forgot about that earlier, but this is okay now. This is not that bad. This is equal to 1, and the deal is that you see that we have the a squares. Okay, let's see what will happen. We have the a squares, so I will write this down as a squared plus b squared plus c squared. And you will just see this is, combinable. We will just combine like terms. You have two of this, two of that, two of that. Everybody has the two twos, right? So of course we can factor out the 2. So we put down plus 2. And this and that, we'll just put down the AB. And the next one is plus BC. And then lastly plus the AC, like this. And this right here will still be equal to 1, right? Because this is just the expansion for that. So that's not that bad, because now you can actually solve for this part. Really cool, huh? So I told you it's just a lot of algebra for that. We know this guy is just 2, so that's nice. Very nice. All right, so this right here is just 2. Why? Thank God, right there, the equation gives us just a 2, which is really, really good. And then plus, this is 2 again because you have to combine all the terms. AB plus BC plus AC, and this is equal to 1. And now let's do a few things in your head. Minus 2 on both sides, you get negative 1. Divide 2 on both sides, so we know. Let me just first put down, now we know. Put down no. I mean, I want to put down, we know. Now we know this guy is equal to negative 1/2. Oh my God. AB plus BC plus AC is equal to negative 1/2. So if I put in here, then the last part I need to figure out just the ABC, then we'll be done, right? So, here is the deal. How can we produce A times B times C? The truth is that we will have to raise this to the third power. That's how we can actually, get the A multiplied with the C, multiplied with the B, all that. Because if you look at this earlier, it's just actually 2-dimensional multiplication. We have to have the 3 things together. So now another observation. So perhaps I will box this in red. I think this is really important, so I will box it. And of course, you can come with a lot of identities already, but just show you guys all this. So observation, raise both sides of this equation to the third power. So A plus B plus C, and we know this is equal to 1. Again, we raise both sides to the third power. Okay, you have 2 choices. One is you can just multiply this expression by another A plus B plus C, or another thing is that you can learn some new things, which is the one I will show you. So this is called the trinomial expansion formula. It's really cool, but to be honest, sometimes maybe you just want to end up with just multiply this 3 times on your own instead of using the trinomial formula. So I just want to be honest with you guys, but here's the deal, okay? So the statement says if you have A plus B plus C again, this is just a trinomial, right? So a plus b plus c. And sometimes you may have more things such as like, 2x plus like 5y and then minus like 2z or like 7z or something like that. I don't know. Let's say we have this raised to the nth power. Then in this case, we know this is equal to the sum. And because you have three things, so you actually have to use like three indexes. What you're going to do is, first of all, you are going to use the trinomial coefficients. Not the binomial coefficient, but the trinomial coefficients. And what you do is you look at n. And again, you are going to use three indexes, or however. And I'll just code it to be I, J, K. Okay? Not IDK, but IJK. And then you are going to have a to the i's power, b to the j's power, and c to the k's power, like all this. Whew. Okay. And what's the connection between what's the connection between IJK? Well, the connection is that a plus j plus k, they have to add up to be n. And of course, for now, let's just talk about this as n being positive whole number. If n is 0, that's like the best day ever. If this is 0, then of course we know the answer. It's very nice. It's just equal to 1 unless the inside is also 0. And another thing I have to tell you guys is that what is this then, right? So I will have to tell you where the trinomial coefficient is calculated as the following way. N, and I don't know how to say this, like n choose IJK, I don't know, but like I'll just put down n IJK. This right here, to compute it, it's really similar to the binomial coefficient. If you look at n choose k, for example, this right here, the binomial coefficient is n factorial times k factorial times n minus k factorial, right? But the deal is that if you can code this to be something else, let's say you have a j. So you can code this to be j, where j is, well, the number so that j plus k is equal to n. Then it's just n factorial over j factorial times k factorial. Now you have three things. It's the same idea. You are going to do n factorial divided by I factorial. Of course, this is not the imaginary number I, so don't get too excited. And then you have the j factorial and then the k factorial. Okay, so that's how you compute it. Very similar to the binomial coefficient if you look at it this way. Okay, now how exactly are we going to do this? So, let's see. Calm down first, because seriously, we need to. Let's see. I think I have to write it down here. I will say, I don't know. Let's see what we can do right here. Okay, so perhaps I'll just continue working here. In our case, of course, n is 3, and the sum is you have to just vary the IJK, and you have to make sure that all this IJK add up to be n. And perhaps the best way is you're just going to fix a number and keep it to be a number, and then just kind of vary it. Okay. Another really interesting question is, okay, our case is n equals 3. And I have to look for I plus j plus k equals 3. How many solutions do we have for this right here? Non-negative integer solutions to this equation, ijk. Right? So this is also a very interesting question. You can kind of just count, which we are going to do that because this question is for the next video. For the future video, you can talk about it by using the generating function, but as I said, that's for later on. Now, here's the deal. I will just keep the k to be 0 first, and I will write down the coefficients for you guys. And this is how you get the Pascal's pyramid entry, right? So, this is how you can do it. Let me write it down here. I hope we have enough space, right? So, the first one is that I will have the n being 3, of course. And as I said, I want the first row to be where k equals 0. So we have 3, and you have 0 here. And now you have just I and j. You have to think about what plus what is equal to 3, right? Plus 0 is going to be 0. I mean, to be 3. So you can do it as 3 times, 3, 0, 0, right? This is the first one. And when you put this down again, this right here tells you the power for the A, and this right here tells you the power for the B, and this right here tells you the power for the, no, I still put it down wrong. Sorry. I did fix it, okay? So if you comment it, let me just tell you, in minute 20, okay? I did fix it. Anyway, this right here tells you the powers, right? Okay, and I'm not going to write it down, seriously, just kind of keep that in mind. So this is the first entry, and the next entry is going to be 3, and then again, I will keep this 0, so perhaps I can make it as 2, 1, right? And then next, I can have 3, and then 0, and then maybe I will do 1, 2, like that. So that's pretty good. And I can also do 3, and then 0, 3, 0, isn't it? Yes, it is, of course. That's the first row where the k is 0. Now, the next row is, of course, with the k is equal to 1. And you actually will have, one less entry, because right here you have 4. Now, the next one you have 3. It's really similar to the Pascal triangle. But anyway, 3, k is 1. And think about it, how can you do it? You can put down 1, 1, 1, but let's keep it in a nice order. I will start with a bigger number 2, and then 2, 0, 1, right? And then the next one, I'll just put down, okay, 3, and then 1, 1, 1. And then next one, 3, and then 0, 2, 1. And recently, you guys have been telling me you guys like to hear the and then. So perhaps I'll do the rest as and then. Anyway. Next one, 3, and then I want the k to be 2. So I may have 1, 0, 2, right? And then the next one is 3, 0, 1, 2, like that. And the last one is just 3, and then the k is 3, and then 0, 0, like this. So you have a total of 10 terms. Yes, earlier the question is, if you have I plus j plus k equals 3, in fact, you have 10 ways to make that happen. Suppose the order matters, and also non-negative integers, right? So 3, 0, 0 is different than 0, 0, 3, right? That would be considered different solutions. Okay, so now I will write this down. We're not doing integrals, but I know this is just like an integral sign. When we expand this right here, first you will have this guy as a to the third power, and let's see, we get a to the third power here, right? And this right here, okay, let's do this in your head. 3 factorial, which is 6, divided by 2 factorial, 1 factorial, you get 3. In fact, this is 3, this is also 3. So you have plus 3 a squared b squared. I mean a squared b to the first power, right? Plus, and this right here, again, 3 factorial divided by 1 factorial, 2 factorial in the denominator, you get 3, and then this is a to the first power, and b to the second power. This right here corresponds to b to the third power, and 3 factorial divided by 3 factorial, you get 1. So I will just put this down right here, and then we plus b to the third power. And this right here should remind you guys about the usual binomial expansion. A plus b to the third power. Really cool, huh? Now, c is coming in, right? So we have the c term because k is 1 now. So right here, again, 3 factorial divided by 2 factorial, and 1 factorial is 3. So we will have to add the 3 here, and then this is a squared and c to the first power. And we add, this right here is cool because it's 3 divided by 1 factorial, 1 factorial, 1 factorial, which is going to be 6. So we have 6. And then we have to have a, b, c. And in fact, let me write it down better right here. So this is plus 3a squared c to the first power earlier. And then this one gives us 6a, b, c. And the next one, this right here gives us 3b squared c, right? And then we continue. This right here will correspond to plus 3ac squared plus this right here will correspond to what? 3bc squared. And lastly, oh my goodness, plus c to the third power. All that. So all this stuff, they will add up to 1, believe it or not. So all this is equal to 1. And of course, now this is the time for us to do some factoring and all that stuff. So as we can see, we have the to the third power, b to the third power, and c to the third power. So we know a third power plus b to the third power plus c to the third power is no, not yet. We have a lot more to go, of course. Let's see. Let's see. Right here. Let's talk about factorings, yeah? So we have this term and this term. I think there's one more guy has the a square. Well, no, a square somewhere. We should have another part with a square. Actually, we don't have another a square, huh? So I will just factor the a square right here. So we plus. Let's factor out the 3. Let's see. Check this out. 3, 3, 3, 3, 3, 3. They all have 3, so I will actually factor out 3 for a lot of things, right? So these guys right here, they all have 3, so that's very, very nice, right? And if I factor out a square right here, I will get a square and then b plus c, yeah? So I'll just do that right here. I don't know what's happening, but like I'll see what will happen. And then this right here, I can factor out the b square, so I'll put down plus b square, and then this will give us a plus c. Okay? And this two, huh? So I can factor out the c square, so I'll put this down right here, plus c square, and I will get a plus b. That is kind of nice, and this is still equal to 1. Yeah, let's see what happens. It's really interesting, actually. And oh my god, I think we have to do this trick again, huh? Because we noticed that we have the b plus c, which is the same as 1 minus c because we can use the original equation over there. So this right here is 1 minus c, this right here will be 1 minus b, and this right here is 1 minus c. Sorry, this right here should be 1 minus a because I will have to minus the a on both sides. Yeah, so this is 1 minus c. 1 minus c right here. And all that stuff. Okay, so distribute this guys, oh god, man. But we do know this part is equal to 3. So I just put down 3 right here for you guys. So this right here is 3. So that's taken care of already. And right here we have to add, we have another 3 right here, and let's see, a square times all that. Okay, we have the a square. So we have the, let's do the first part in black. We have the a square right here, right? A square, and then b square plus b square, and then the c square, of course, plus c square. Hey, we got the a, b, c somewhere, right? No, this is still the, where's the a, b, c though? Oh yeah, oh, I forgot to write down a, b, c. I forgot to write down 6 a, b, c, sorry. And let me just put that in all the way in the front. This right here, it's plus 6 a, b, c. Right, so that. Yeah, cool. Okay, so all that, and then you have to have the minus, and that's the a cube, and then you have to minus the b cube, and then you have to minus the c cube. Cool. Like this. And earlier I forgot the 6 plus, let's close this guy. We have to put on the 6a, b, c plus all that, right? So this is still equal to 1. So now, let's see. Okay, so I will keep the 6 right here, and with the ABC, of course. I will minus 3 on both sides, so keep that in mind. I'll minus 3 on both sides, okay? So I will put on this 3, and let me just indicate that. Minus 3 on both sides, so this is out. A squared plus b squared plus c squared, this is equal to 2. Finally, we use the 2. Huh. Oh, actually, we used it over there. Not that exciting, sorry. And then minus this, and of course, we can factor out the negative, and then all this part right here, the cubes is the 3, so we can minus the 3 right here. And this right here is equal to negative 2. Sometimes, in fact, if you remember the formulas, the identities, you can actually just write it down all that. But again, this is extreme algebra, the extreme algebra question, all that. Let's see. And here we have the 6abc. Let's do this in our head. 2 minus 3 is -1. So here is -3. So 6abc minus 3 is equal to -2. So we add a 3 on both sides. So that will be +1 and divide 6 on both sides. So ABC is equal to 1/6, like that. Okay, so now we know this much better, huh? So ABC is equal to 1/6. And in fact, this is a really famous, well-known question, right? Really famous, really well-known question. ABC is equal to 1/6. But we're all adults now. We're all adults now, so we are going to do the 5th power. Okay. Well. A to the 5th power, all that, minus ABC times this is equal to this times that. So in the end, we just have to do the following. Right? So let's do this in our head. A 5th power plus B to the 5th power plus C to the 5th power. This right here, you have an identity. You can just move this to the other side. That's not identity. We did hard work for that. This right here is equal to A squared plus B squared plus C squared times A 3rd power plus B to the 3rd power plus C to the 3rd power. And you add, let me just put down, we add ABC times AB plus BC plus AC, like that. So let's see, what do we get? All right, A squared plus B squared plus C squared, this is 2. And we multiply by this right here is 3, right? And then plus ABC is 1/6. So we have that right here. This is perhaps, oh, just put this on in red. 1/6. And this part right here is a bunch of dot like this. This right here is equal to -1/2. So we multiply by -1/2. Like that. Shit, something's wrong. Okay, so I'm not going to lie. I paused the video and double check. And I forgot this guy right here. A squared plus B squared, all that stuff. So, and to work on that, we will have to look at this and square both sides. And by now, you guys should have enough time to look at this already. So I will erase that. And hopefully, I can have enough space to fit in everything in here. And we'll figure out what that expression is, okay? So again, let's make an observation for this expression. And to do so, again, we will have to square both sides. Let's take AB plus BC plus AC equals -1/2, not -1/12, okay? And the reason that you take this and square both sides is because that's how you can produce the A squared, B squared, and all that stuff, of course. So we will pretty much do the same thing as what we did earlier. And if you would like, you can just write it down twice, right? And then just kind of multiply out by hand and all that stuff. So let's see. Okay. I will just write it down twice for you guys to make things easier for you and for me. Okay, so I'll just put down AB plus BC plus AC, and then another AB plus BC plus BC. Or just do it on your own, right? One or the other. Anyway, here we go. So AB times AB, of course, is A squared, B squared, and that's exactly, the first term that we have over there, so that's good. And the next one is AB times BC, so it's going to be plus AB squared C. And then the next one is going to be this times that, which is going to be AC. This is supposed to be AC right here. Okay? And then the next one is going to be AB times AC, which is going to be plus A squared BC, like that. Okay? So again, you just write this down twice on the side and then just multiply all that stuff. Okay, next we have to take BC times this, which is going to be AB squared and no, BC, so A with a C, right? BC times this, so it's B squared and AB squared C. And next you take this times that, B is being squared, and then you have the BC, both of them being squared, B squared, C squared, which is nice. And now you take this times that, you get A, B, C squared, like that, right? This times that. Yes. And lastly, you take AC times this, you get A squared BC, like this. And you will have this times that, which is ABC squared. And you will have to do this times that, which is AC squared. Both of them being squared, like this, A squared, C squared, like that. And of course, on the right-hand side, this is just nice. It's just positive 1/4. All right, so a lot of algebra today, huh? Now we'll see. This is exactly what we want. So perhaps we just put on A squared, B squared plus B squared, C squared plus A squared, C squared, right? The diagonal. And you see that, in fact, we can combine like terms here and here. So we'll have two of them. And this and that, we can also combine like terms. And this guy and this guy, we can also combine like terms. But the deal is that, okay, everybody has the 2, so I'll factor out the 2 right here, right? 2 of them. And you see that everybody have a factor ABC. So in fact, we can just factor out the ABC first, like this. And I'll put on another parentheses. And you'll see that for the first one, when you factor out the ABC, you have the B left. And then for this and that, when you factor out the ABC, you have the A left. And then for this and that, you will have the C left. So it's pretty much ABC plus right here. And then this is equal to 1/4. So that's good. So now, this guy is what we're trying to find. This guy, oh my God. Let's see. Oh yeah, so good. We have the 1/6 right here. We can use that. So of course, so we have the plus 2 times 1/6. Also, thankfully I did this first. So, and then you have the ABC, which is equal to 1. And this is equal to 1/4. And you have the A squared B squared plus B squared C squared plus A squared C squared, right? This quantity is what we are trying to find out. Now let's do this in your head. This is going to be positive 1/3. Minus that to the other side, you get, let's do this, 1/4 minus 1/3. You get your common denominator, which is 3 here and then 4 here, over 12, right, for the denominator. So you get negative 1/12. Negative 1/12. Oh my God. We end up with negative 1/12 as well. So this guy here is just equal to negative 1/12. Perfect. Now, here is the deal. You see earlier, I put this down to the other side, so we add it here. But the truth is, I will also have to erase that, and I'll have to do that again. Because I will have to bring this guy to the other side, and that's a minus. So I will have to minus A squared B squared minus, right? Everybody's, well, let's do it like minus parentheses plus B squared C squared plus plus A squared C squared, like that. Okay, hopefully everybody is good now. So finally, this right here is, let me actually erase that. Let me just write it down legitimately. A squared, no, A to the 5th power plus B to the 5th power plus C to the 5th power is equal to this guy, which is 2, right? This is 2, times this guy is 3, so that's nice. And then plus, this right here is 1/6, as we discussed it earlier, right? 1/6, which is the one that's above us, right here somewhere. So this is the one that we got, and then this part is the negative 1/2. So we multiply this by negative 1/2, and you minus all this guy here is equal to negative 1/12. So you have your negative 1/12 already here. All right, so you have the negative 1/12. And as you can see, of course, this is positive. That's negative 1/12. So this and that will cancel. So, ladies and gentlemen, a to the 5th power plus b to the 5th power plus c to the 5th power is equal to 2 times 3. I told you it's 2 times 3. That's how we get the 6. So I could have ended this video about like, I don't know, 40 minutes ago or something like that, right? So let's see. I will just box it here somewhere. Oh, it's boxy right here. So here is the answer. This is the legitimate answer. So this right here is it, right? Box the final one for you guys. Okay, that's it. So a lot of algebra right here, and hopefully you guys all like this video to a certain degree because I did show you guys the interesting part, which is the more like a discrete math approach, the trinomial coefficient, and also we can talk about the, if you have how to find the number of solutions, the order paired will satisfy like x plus y plus z is equal to n and non-negative numbers and all that stuff. So I will have those videos for you guys later on, but as of now, this is a pretty classic math competition question, but we are doing the 5th power instead. The famous one is this one. a, b, c is equal to 1 over 6, which you could have stopped this right here about like 15 minutes ago or so. But this is cool because, you see, 1 for the 1st power, 2 for the 2nd power, 3 for the 3rd power. But for the 5th power here, you get 6. Legitimately 6. Hopefully, you guys all like this video. Right? If you guys are new to my channel, be sure to subscribe for more math content. Thank you guys so much. As always, that's it.